Persians, and today is the first day of spring. So happy spring and happy New Year to you. We brought you some traditional Persian sweets.
It's right at the back.
Right at the back. I hope you enjoy it. I hope you like it.
Try it. Thank you.
Thank you.
Thank you.
Yeah,
Yes,
awesome. So
that's it.
we're gonna take maybe 30 minutes of your time. I know you guys are busy getting your project done. I'm really excited. I'll be part of the judging team tomorrow. So really looking forward to see your amazing project. So we start with just to tell you agenda, a quick introduction of Edge AI Innovations by Tara. And then I will tell you about our offering. So we have a full course on Edge AI. We'll be making it available to you so you can use it. And we have a platform for testing, and it's our MVP, so it's free. You can test different models. You can test small models, LLM models, and a serverless RAG architecture. And then we have also announcements to make for the future. So I hope you enjoy it. Go ahead.
Thank you, Majid. Okay, let's start. There are going to be more people coming, but we got the green light to start. So who we are, Edge AI Innovation is a platform for accurate, scalable, secure AI for enterprise, using our own serverless vector search engine. So who we are, Majid already talked about us. We quit our job 9 months ago, 14 years in industry, different software and hardware industry. We always wanted to have our own business. So the last job we had, we worked at Saudi. I was an engineer. I moved to enterprise sales leader, and Majid was leading a data scientist team. So we were selling the biggest customers in US, and we figured now we're going to do our own business. And yeah, so we are a team of 2. We have some interns. I mean, they're going to be our interns. And we will expand our team soon. We're just, you know, at the moment, we are having our MVP and launching, but soon it's going to be there. So right now, what's the problem with enterprise? Let me ask you guys, who knows if enterprises, when I say enterprise, big companies, are using AI, and if they're not using, why they're not using? Privacy, perfect. Security. Exactly, what else? Consistent results, it's not there, yeah. What else? Anything else? Inaccuracy of the models. So the same way that individuals are using AI, it might not possible for enterprises, right? Because there are consequences for not having secure results. So here's the problems with the enterprise. As you guys mentioned some of them, poor retrieval, hallucination, accuracy, scalability concern, right? What if the amount of documents is big and it's getting bigger? Security. AI assistants are vulnerable to various security threats, data poisoning, misinformation, toxic input. So how are we going to resolve and solve these problems? We have fully serverless agentic RAG. So Majid is going to talk about what RAG is. I'm sure some of you guys know about it. So we are a serverless vector database, and our retrieval accuracy is increased by 40%. So we're doing a lot of benchmarks to prove that. So here's our product. As we are claiming that we are 40% more accurate, 32x less memory, and 100x faster computation. So what does that mean for companies? That means that this, yes, better ROI, right? They're going to spend less money for the same amount of efficiency. So again, this is Murche, our product, serverless RAG. It's available right now. Majid is going to do a demo for you guys. You know, people can go and use it. So no vector DB, no server, built-in re-rank. He's going to talk about all of them. this is us. So feel free to add me, Majid, and the LinkedIn. We are, if once you use it, you have a feedback, you are using GitHub Medium, you're doing some comparisons, reach out to us. We really, really like to hear from developers and students. That's our website, and that's just, you can feel free to scan it. That's it. So,
Yeah.
Majid, go ahead.
Thank you very much.
Yeah, no problem.
Yeah, so I will just share our website and start. So if you go to our website, which is edgeaiinnovations.com, if your project, if your hackathon project is something you want to deploy on small devices, on edge devices, we have a lot of resources that can help you. The first thing is if you go all the way to the bottom of the page, now we have a full Edge AI course, which is the essential knowledge that you can quickly get up to speed with what is Edge AI, what are the challenges for deploying AI on smaller devices, what are the available commercial devices like Jetson, NVIDIA Jetson, or Intel, or other providers of hardware. And it also tells you about the platform, software platforms that you can pair with it and experiment and deploy. It's a bit demanding, so you need to know basic programming, machine learning. A lot of edge devices run on Linux, so you need to know a bit Linux programming and and hardware familiarity, and then mathematical foundation. So that's the course description and demand. It has been designed in 2024, but just got updated because the whole industry is changing so rapidly in the information. So I don't want to spend too much time on it. It's just in case you want to get some quick information and knowledge about what Edge AI is and how you can deploy things on Edge. You can go and download the whole course and study it. So it starts from TensorFlow Lite, PyTorch Mobile, Edge Impulse, which is a full platform. They were just acquired by Qualcomm just the last week, or last 2 weeks ago. But that's a very comprehensive platform, and you can use a lot of free software from there. OpenVINO was introduced by Intel. There's a lot of, again, good software for Edge AI. And NVIDIA itself has a platform. Microsoft, AWS has Greengrass, which we use a lot. Google, Coral, IBM Edge Application. Onyx, which is the Open Neural Network Exchange, and many other platforms. Then it would tell you about hardware selections, all kinds of different hardwares that are used at the edge, microcontrollers, single boards. Yeah.
Is anybody familiar with edge devices?
Use you.
Is anybody familiar with like edge devices, what they are, why we use edge devices? Just okay, so maybe just to give
Yeah,
an
okay, so
explanation.
yeah, it's actually very simple. It's when instead of sending your queries or your demands to the cloud and using cloud, you want the response on the device. It could be on the phone, right away do all the calculation or inference on the phone, or it's a camera, the camera could be smart itself, or you do the image processing on the camera hardware. So for that, you will need AI accelerators. So you load the AI model on the device. Let's say it's a camera. That camera is not a normal camera anymore. It's a camera with AI on the spot. So it can detect objects. It can, for example, you can program it to recognize some boundaries, and only when someone passes that boundary sends you information. So you don't need to record that camera, or it doesn't need to be online all the time. So it does the processing on the spot.
And low latency, you know, real-time analysis for
Yeah.
remote areas that don't have internet.
Yeah.
So there are a lot of advantages
So-
of edge
And
devices.
the biggest challenge for running AI on the device is resources are limited. So you have limited RAM, limited memory, limited computation. So usually we either use accelerators or a specialized hardware to do the inference, for example, AI inference, run the neural networks. And then you also need to compress the models to make them more efficient on the tiny devices. I just passed through quickly because there's a lot here. And then it tells you about real-time inference and deployment strategies, security and privacy, and provide some case studies and hands-on projects, which you could consider for your next projects if you want. For example, if you have an AI project right now and you're thinking of moving it into edge, running it on edge devices could be a good resource, and so on. And the last section, which I had to update it more frequently, is running the generative AI on the edge. So the biggest models or most demanding models are edge, like our generative AI models. And to run it on the edge, you need to test everything. You need to know how much resources you need, how fast it's going to respond, how many tokens per second it's going to be able to respond. And to do that, we have another resource on our website, which is our the first product that Tara mentioned. It's called Murche. And Murche in Persian means ant. It's tiny but mighty. And you can try it. It's an open, it's open and free platform that you can use for benchmarking or testing. And it's basically a serverless RAG architecture. It's based on AWS, the backend. But what happens is that you just need an email to log in, and you can upload documents. It supports PDF, doc, CSV, PowerPoint, JSON, or any kind of data you have. And automatically it chunks it up, does the embedding for you, and it's ready. Then you can go to Chat Playground, and you can choose models. We have support for many different versions of Llama, especially if you think of deploying your own LLM with the model, everything on the tiny device or on your billion, 3 billion, or 70 billion, 90 billion, depending on how much resources you can afford to have. We also have DeepSeek support. DeepSeek, this is version 1. And Anthropic Claude, you wouldn't be able to deploy on-prem, but it's good for testing because we also have support for Claude 3.7, which is the newest model. It's almost on the same level as the most advanced benchmark for Gen AI. And Amazon Nova. Anyway, once you choose your LLM, then you can chat with the documents that you have uploaded. Here I have uploaded a book on like pharmaceutical chemistry. This is like a full book on pharmaceutical chemistry. And then you can ask questions about the chemistry. Anyway. Okay, tell me. Okay, so I said, tell me about acid and base in in drug chemistry, okay? And once you submit the question, what happens is that behind scenes, it's all serverless architecture. It means that there's no servers running. It just runs a cloud function, fires up the cloud function, does all the inference that's needed, and then takes these chunks of the relevant information from your document, and then passes it to LLM and gives you a response. So this is a normal RAG. But what is different here is the score that we use and the label helps you to anchor this responses more accurately. And that's where the accuracy comes. Because normal RAG systems or retrieval augmented generations, you might have some relevant pieces of information returned to you, but you would have to pass them through re-rank. Here, it's built-in, it has a built-in re-rank, and it also gives a label. So once you pass the label to LLM and you tell the LLM that pay more attention to a piece of information that is more relevant, that gives a boost to the accuracy in the response. So it makes it more focused on what you provide. So we have some benchmark experiments that we did. It's on GitHub. I will share with you later. But another capability is that if you want to limit the conversation to the context that you have, okay, you will need to add more layers to your LLM and make it more secure and more anchored on the context. But here, you don't need to do anything extra. So it's already built in something we call kiosk mode. And let's say if I ask an irrelevant question, so here I ask, what is the capital of France? And if you submit the question, so it still goes through the RAG system, and the response from LLM is Paris. So this is a correct response, but it's not related to what you are building, right? So it's your assistant is not supposed to answer all kinds of questions. It's supposed, in this case, to say, my assistant is supposed to know about chemistry of drugs and pharmaceutical chemistry. So easily here you can just turn on the kiosk mode, and what happens is that it looks at the scores, and these scores are universal scores in terms of semantics. So when you turn this on and you ask these question that is not relevant, it detects it. And so you can either do another, stop the conversation or redirect conversation to the topic that you're working on, or you can also do other activities, like do a search or submit it to an AI agent to do other activities, basically. Any questions so far? Yes.
We give them
I know that one source is the book, but what is the other source? I know that is Faust.
Yeah. Good question. Yeah. Faust is a story from 18th century German poet. And I used it, first of all, because it's in public domain, and I used it for running an experiment, okay? The experiment is, how do we find the quality of deep questions, let's say. Because this is a story of a scholar in like 18th century who knows all the knowledge and science of the day, but he's not satisfied, so he has a pact with the devil to explore. Okay, so that's the story. But then I submitted the same file. It's in public domain, so you can find it. I gave it to GPT and Gemini, and I told them, ask deep questions about the story. So, like, describe Faust's happiest moment in the story. Okay. and or describe FOSS' deepest regrets and disappointments. So generally, when you chunk up a data and you do RAG-based systems, it's difficult for that system to answer these kind of questions. Like the questions that require deep understanding of the story, it's not easy to answer when you only have a RAG. So what I did was I did a test of Model A and Model B. Model A is based on LanceDB, and they do like a Euclidean distance metric in terms of vector distance. And Model B is our search method, which is based on information theoretical similarity between vectors.
Okay.
And the result was that, in general, keeping everything the same, like the chunking mechanism the same, embedding is the same, everything's, and the LLM that's responding is the same.
Yes.
The only thing we changed was the search method. Like vector, what is the definition of vector similarity? And that's what we did. And it turns out that it increases the accuracy, especially if your questions are more about the meaning, not just the words or keywords. It's not a keyword search, but it's a meaning word search. Yeah.
It could be a difference with ChatGPT. You are not working with the next keyword. You are working with that the model learned before
Yeah.
with the questions. Okay.
Yeah.
And I have another question, but
Yes,
after.
go ahead.
Okay. In the accuracy, what is the rate of accuracy? Because I know, for example, when come without is 0.003. Yes, when come from false. But in other case is 0, that is in the book, the information when you show is 0. That's 1. What is the rate of accuracy that you are working?
Yes. We have, by experiment, we have set up thresholds, and I can show you. So if you go to system prompt, actually you can change this, okay? This is the prompt that gets sent to the LLM. But here, we are defining these thresholds. So anything above 0.8 is considered close match. Okay? Anything between 0.4, 0.8 is very high relevance. Then you have a strongly related content, high relevance, and then good relevance. Anything below 0.1 is low relevance. And anything below 0.01 is like irrelevant. So this scale is different. So 1 means exact match, and 0 means no information, no mutual information content between the two semantic vectors.
Okay,
Yeah.
thank you very much.
You're welcome. Any other question?
Maybe we'll have more questions.
Okay.
Yeah, you want to ask one question?
So I was curious, are you using a vector DB on the backend to store the embeddings?
No.
Right.
So our method actually, what it does, it replaces the need for vector DB.
Right.
The algorithm is so lightweight that we just have a container-based solution that runs on a Lambda function, or could be cloud function on Google, doesn't matter. It's just a Python wrapping that does the compact, makes the embedding compact, like 32 times more compact, makes it actually into binary.
Right.
And then does the binary search within the embeddings. So it's much faster, but at the same time, you gain in accuracy. So that's the...
So if you guys are interested, once you log in and sign in and use Murche, because we are working on our API interaction, it's going to be ready soon in a month. Whoever uses, we can get back to you and say you can go use the API, because it's going to be very selective with the API. So yeah, if you log in and upload your documents, then we'll have your list, so we can let you know
Yeah, we will
in a
give
month.
you early access to the full product that's coming out. It's going to have different sections. So it's going to have the API, which is you can just use the API. You wouldn't need any, for many applications, like easy applications, like the experiments that you are doing or projects that you are doing, instead of installing a vector DB, managing the vector DB, and all of that.
Re-indexing.
You just do your embedding, send the embedding to through the API, and anytime you want to do an inference, you just call the API, say, this is my embedding of my query. Give me the index of the most relevant text, and it just gives you the index right away. So it takes maybe, the benchmark that we have for up to 1 million vectors, its response time is less than a second. So it scales up pretty quickly. You should add maybe the delay for the API gateway. That's maybe 60 milliseconds, 80 milliseconds, but the computation itself is really quick. Right? And then on top of the API, you will have serverless cloud, which is the architecture that I showed you. That would be like available for implementation on AWS. So it's based on CDK. Oh, it's based on CDK. So it's just a turnkey solution. You can deploy the whole thing on your own cloud, and or you can just copy the container and run the container on any cloud, and then we're gonna have the edge version of it, which is a container optimized for running on Linux-based tiny devices. So then you can have your entire RAG system or AI assistant with your LLM, let's say Llama 3 billion and the RAG, everything on one tiny device. Okay, so that's our ultimate objective. And we also have AI chatbots. So on the same platform, we're gonna have the ability, once you upload, let's say the context data, let's say chemistry expert data, you put it on there, and then you can export it as an chatbot right away. We just choose the skin and use the chatbot on your website or application. How much time we have? Okay, we'll be quick. The technology behind it is the algorithm itself is patent pending, but a lot of the software that is around it would be available for free, especially for research and so on. And this is how the architecture would work. It would be very efficient and cost-effective way of doing the creating AI assistants without without being locked into any LLM, right? So you can switch the LLM from Anthropic to Llama to Gemini to GPT at any time you want, because this this section would be separate. It will also it also creates automatic graph representation of the data, and the graph comes from the score, relevance score, because once you have the relevance of all pieces of the data, you just turn it into a graph automatically. Anyway, so the last thing that I just wanted to mention is that we are collaborating with another company, and they are providing APIs for audio and image tools. So we would be providing the chatbot, so you can create your chatbot and RAG and chatbot on our platform, on our APIs, and then you can pair it with their API to create realistic agents with voice and face and acting. So you will have a full spectrum of creating human-looking and question and answer. Yeah, so.
We can get you credits because we are partner with them. So if, let us know if.
Yeah, if you're interested, let us know.
Just put it closer to you.
much questions. I'm sorry. You told before about a course.
Yeah.
We need to pay for that?
No, it's free.
It's free?
It's free. It's
With
on
the
our
credits?
website.
I will be.
If you go on our website and scroll down, by the way, there are demos and tutorial here. You can
Yeah.
watch about
Watch, I recommend watch that demo before you guys log into Murche. So it's just explained.
Yeah, and we also organize AGI Innovations Summit every year in Toronto. It was on November at U of T in Schwartz-Reisman Innovation Center for AI. So watch for that. We're going to organize another one. So if you're interested in AGI, make sure to check our website and get the updates. But as I said, at the end of our website, there is a button that says download AGI course. You say it's free and get the PDF.
Yeah, and I'm curious to know if, like, other than you, anybody else working with vector DBs? Anybody else? Vector DBs, databases, yes, like for your use case, projects, hackathon. Yeah, okay, okay. Because we just need to know, like we're gathering this information to know how familiar you guys are, right, with RAG, and so we can create some content, because we create a lot of knowledge transferring, we do create a lot of contents on our LinkedIn. So if you know that, like, you guys are interested to know about vector DBs, what's out there and what's the pros and cons, we can create one.
Okay, yeah. So our presentation is done, but if you have any question, we have like 5 minutes of question and answer.
Come on, guys, questions, yes.
You know, on one of the slides, you mentioned that behind the scenes, you're not using a vector DB, but instead you're using something called a binary vector. Could you explain what that means?
Yeah, that's part of our like patented method.
Maybe, Majid,
It's
can
the
you
yeah.
explain like what vector DB, because nobody seems like just two people are familiar with transformers and the vector DBs.
So, so vector DB is databases that are very good at handling large number of vectors. And each vector is basically 1,600 or 2,000 or 3,000 float numbers. Right? That's usually the last hidden layer of a trained transformer or embedding model anyway. And dealing with that, and a normal text turns into, when I say no, every page of a text might turn into 4, 5, 6 vectors. So when you're dealing with thousands of pages of documents or hundreds of thousands of pages, then you have to store and handle hundreds of thousands or millions of vectors. And very quickly, it gets very large in terms of its size. And then all the operations done on them are the float number operations. For example, Euclidean distance is like x1 minus x2 plus x1, like x1 minus x2, y1 minus y2, z, and so on. And then you have to take the square root of it. So during the past couple of years, the vector databases have emerged to do that operation much faster. Okay, so what we are doing is we are using some information theoretical context. So this Shannon's theory of information basically tells you that if you have a channel of signals coming in, there is an optimal way of turning them into zeros and ones by losing the least amount of information. And that's how we do binarization. And then when you have the binary, it's much faster to do all the process, right? Because when you have a binary vectors, you can do Hamming distance, which is the XOR, which is the most primitive thing that the processor does, and it's extremely fast, and it's parallelizable. So when you do the XOR, so you gain in the speed, And then we have a method at the end, which is our built-in re-ranker, that extracts the lost information as much as possible. So that's the inverse of the information theory that we use to encode. So when you use it to decode it again, to gain the accuracy back. So together, these three components together gives you a very efficient search, which is not compromising on the accuracy. So you gain in accuracy and you have efficient computation. And that's the core of our Murche search.
Any other questions? Yeah? Yeah? Okay, you can speak loud.
No, it is a lossy it's a lossy process for sure, because you're going from float numbers to binaries, and even a smaller amount of binaries than you had. So it's at least 64 or 32 times less information, less volume in the less volume in the memory. And then the good thing is that you can put it back into your normal database. Whatever database, so in that case I'm using a DynamoDB, you can use Firebase, whatever normal database that you use for other operations that you have, you can keep those binary representations there. And only when it's time to do the inference, you bring them back, you do the inference, and use them. Yeah? Yeah, you can keep them the same. You have an option. But the experiment is the same number of features. It just, they turned into binary. Yeah.
Question? Yeah.
When we can start to test the platform? Yes.
Yeah, I would say within a month until I think April.
I think so, like mid-April. Yeah. We will be
Let's
traveling.
let's say end of April.
End of April to be safe. But like, if you guys follow us on LinkedIn, we're gonna announce it. We're gonna let everybody know we'll be launching it. So, yeah, just.
Yeah. Okay. Thank you very much.
Thank you, guys. Good luck for tomorrow. Okay.